Good afternoon to everyone. This is Dr. B. Polaiah, working as a professor of IT, Institute of Aeronautical Engineering, Hyderabad. I'm very glad to inform you that on today we are going to discuss one of the image processing syllabus-based topic-based problem solving. Simply, we say a topic on problem solving on Shannon Fano coding. So, such a concepts-based problem solving examples we are going to discuss on today. So, we're going to start that how we are going to be solve or how we are going to use such a concept for taking a problem statement and solving the problem is here. You are going to be understand first of all what does it mean Shannon Fano coding. It is the named after Clade elude Shannon and Robert Fano is a technique for constructing a prefix code based on a set of symbols and their probabilities. So that is technique for constructing a prefix code based on a set of symbols and their probabilities. It is also we can concentrate as suboptimal in the sense that is does not achieve the lowest possible expected code word length like Hoffman coding. However, unlike Hoffman coding, it doesn't guarantee that all code word lengths are within one bit of their theoretical idea, which we return I of x equal to minus log of p of x. Simply we says that I of x equal to negative logarithmic of probability of what we say is probability of x. So that is what we are understanding about. Unlike Hoffman coding, we are going to concentrate Shannon Fano coding. So it is the coding. The symbols are arranged in order from most probably to least probable, and then divided into two sets whose total probabilities are as close as possible to being equal. So all symbols then have the first digits of their codes assigned. Symbols in the first set receive as 0 and the symbols in the second set receive as we noted 1. As long as any sets with more than one member remain, the same process is repeated on those sets. To determine successive digits of the process is repeated on those sets, which we are keeping in terms of their codes. So when a set has been reduced to one symbol, of course, this means a symbol's code is completed and will not form the prefix of any other symbol's code. Of course, we understand a simple theory, but let me start to understand how the algorithm works and it produces fairly efficient variable length encodings. When the two smaller sets produced by a partitioning are in fact of equal probability, the one bit of information used to distinguish them is used most efficiently. Unfortunately, Shannon Fano does not always produce optimal prefix codes. For this reason, Shannon Fano is also almost never used. Like Hoffman coding is almost as computationally simple and produces prefix codes that always achieve the lowest expected code word length. Lowest expected code word length. So Shannon Fano coding is used in the implode compression method. So where it is designed to apply a simple algorithm with high performance and minimum requirements for programming. So let us we take one example. Once we understand the importance of this Shannon Fano coding concept, so we want to understand that the how the problem statement will be defined and how we'll get the required answer. So let me see the example one. The source of information A generates the symbols which A based A0, A1, A2, A3 and A4 with corresponding probabilities are zero point 0.4, zero point 0.3, 0.15, zero point 0.1 and zero point 0.05. So where encoding the source symbols using binary encoder and the Shannon Fano coder gives simple table that is contain source symbol, a probability of given generates of the symbols. Okay, next binary code of corresponding value and Shannon Fano binary value. Okay, so what is this A0 to A4? We consider as L average, and the average value of this also we consider as H, and binary code value maximum will we got as a 3. This is 3, and the value of average which we go compared Shannon Fano with probability values is are the same. But let we concentrate on to understand that the entropy of the source is H. H is nothing but entropy. Such a entropy is here to understand such a entropy value. Such a entropy value is negative of summation I equal to 0 to 4 probability value which varies logarithm base 2 of pi. So submit each values and summing together, then we'll get this entropy of the source. Okay, that we simply say bit per symbol. So since we have five symbols, as which five symbols are started from A0 to A4, such a symbols of values 5 is less than or equal to less than 8, then we represent that in binary 2 power of 3. So we need 3 bits at least to represent each symbol in binary fixed length code. Hence the average length of the binary code is pi into li, average value. What is pi? Your maximum achievement of your L average. So that is L average is nothing but average length of the binary code. Simply adding together of binary value into multiply 3 will get 3 bit per symbol. So thus the efficiency of the binary code also we want to concentrate that eta equal to h by L average. That is the entropy value which we calculated previously, and we know the average, that is average length of the source code is 3, and we got the value in terms of percentage. Shannon Fano code is a top to down approach. Constructing the code tree, we get the average length of the Shannon Fano code is L average is equal to the summation I equal to 0 to 4, that is pi into li, and the value of here which we are multiplying with your pi into li, then we'll get the total average which we called as 2.05 bit per symbol will get it. Okay, thus the efficiency of the Shannon Fano code is, as we got already value, and now with the help of this replacement we'll get 98%. So this example demonstrates that the efficiency of Shannon Fano code is much higher than that the binary encoder. That is the conclusion. Next, coming to the another example that is we can understand in easy manner. Let me to read the statement of the problem. That is example This example shows the construction of a Shannon Fano code for a small alphabet. Their five different source symbols had, suppose 39 total symbols have been observed with the following frequencies, from which we can estimate the symbol probabilities by using the table. Okay, so let me take that problem and rewritten the table with the values of the formula. We know the formula for entropy, that we got 2.186 as per the given information, and now we need to calculate desired word length, that is L average is equal to, you have the negative logarithm base 2 of pi. So here we are submitting such a probability value which we got. So symbols are here also, we are using five symbols A, B, C, D, E, and corresponding probability values are given, and corresponding average length of the source code we find, and word length also we concentrated, and we got final value is this. So we fit code as we are applying formula, according to that we got it. Okay, what is this I? Pi is each value is multiplication. Each value I is varying here, 0 to I is varying, I is varying here is I is varying from 0 to here 4. That is A, B, C, D, and E. These are the source symbols. Okay. So according, based on this source symbol, we founded all the values. Understand? So that is the what we want to concentrate in. You can pick code words in order to choosing the lexicographically first word of the correct length that maintains the prefix free. Okay, and prefix free property which will get clarity. A gets the code word is 0, and B gets the code word may not start from 0, but the lexicographically first available word length is 010, that is for length 3, and counting like this we get following code also. So how we got this? See that alternately we can use the cumulative probability method, which we are keeping in terms of here. It is 0 at 0th place, 1, 2, 3, 4. 0 is here, 1 is here, 2 is here, 3 is here, 4 is here. Okay, now code words in binary. And now, as for this previous table, we modify according to the alternatively, we can use the cumulative probability method. So each is here, we are concentrating not only code words but also word lengths. And the value of cumulative probabilities we keeping in binary equivalent, and we got your binary equivalent code word. That is at 0, at this is 3, 1, 2, 3, like that. This is 4 and 5 and 6. So like that we till we vary. Next, coming to the note that the code words under the two methods are different. The word lengths are the same, but we have the lengths of 2 bits per A and 3 bits per BCD, and E given an average length of bits per symbol. So here we are submitting the values, that is 2 bits per A is here, 3 bits per A, B, C, D is here, B, it is B, it is C, it is D, and it is E value submitted. Then we got the 2.62 bits per symbol. Hence, the expected word length satisfies left LHS equal to RHS. What do you mean this? This is we are checked at the both sides. Next, another symbol which you can understand here. The table has given. What is this table? This is the table which contains the symbol count probabilities of the symbol of frequencies. So all symbols are sorted by frequency from left to right, shown in figure. It is not figure, it is a table. It is a table. Okay, shown in the table. So putting the dividing the between symbols B and C results in a total of 22 in the length group and a total of 17 in their in the right group. Okay, this minimizes the differences in totals between the two groups, what we call two groups. So with this division, A and B will each have a code that starts with 0 bit, and the C, comma D and E codes will all start with a 1, and as shown in figure B. Subsequently, the left half of the tree gets a new division between A and B, which satisfies the A on leaf with a code that is 00 for A, and B on leaf top with code 0.0101. A is 0 and B is 1. So we keeping both values, that after 4 division procedures, a tree of codes results in this problem will be final tree, and the three symbols with the highest frequency have all been assigned 2-bit codes, and two symbols with the lower count have 3-bit codes as shown in the figure. So you can check it this how this root nodes based tree. That is, here nodes are nothing but which we call as A, B, C, D, E are the symbols of which we are going to be applied for calculating the probability values and code lengths. So as per your for having formulas, we submitted your each what we called each symbols based probabilities, and we finally we reached the code length. So the results in lengths of 2 bits for A, comma B and C, and 3 bits for D and E given the value. So here we are going to be use that symbol value 2 bits, nothing but 15 plus 5 plus 6, which we are corresponding 2 bits, and 3 bits are here. Okay, and totally also is the given 39 symbols. So we got we set all that Fanos method with an average length of 2.28 has performed Shannon's method with an length of Shannon's method with an average length of 2.62. That is the your calculated value. Right, next example, the given task is to construct Shannon codes for the given set of symbols using a simple concept named the Shannon Fano lossless comparison technique, compression technique. So that is Shannon Fano lossless compression technique. Symbol A, B, C, D, E. Probability for each frequency of the symbol is given. Shannon Fano code is here also given. Once we had binary values, then according to that binary values, we are formed to get the Shannon codes of the symbols based on their traverse from the root node. So symbol A, B, C, D, probability or frequency we got. So then the symbol and the probability or frequency are taken as inputs. So simply we divided into understanding of the symbols are divided into two, such that the total probability frequency of left side almost same as that of right side. You see left side, this is left, okay, this is right. Okay, so once we compare both are same. That is the what we can observe here. And similarly, the root level 1 and level 2 it is going on according to the your given structure, and that symbols carrying of each one node. So, okay, so that we divided into based on 0 and 1. The values of 0 is here based on the your comparison of binary value. Next, coming to the list of references which we referred for the same examples. Based on this list of references which we can use more for understanding not only fundamentals but solving some problems also. Thank you so much for your given this wonderful opportunity to clear about provide the one of the ELRV on Shannon what we called ELRV video. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.